All right, here's a part two of the alternating series WebAssign. And this one starts out with a question on conditional or absolute convergence, which refers to a alternating series. So basically, um, a, a conditional convergence would mean that the absolute value of the series converges. Basically, the absolute value of this series, if you're talking about an alternating series, means ignore the negative 1 to the n because it will always be positive. Um, Now, if that diverges, then you still want to check if the regular alternating series converges or diverges. And if the actual regular alternating series converges, that convergence would be conditional. Basically, you can say it's conditional that it's converges based off the condition that it's alternating. That's basically what it comes down to. Um, so whenever you see a question like that for absolute or conditional convergence, the first thing you should do is just check the absolute value. So let's check the series 1 over 5 to the n. Well, the series 1 over 5 to the n is a geometric series that converges. So the absolute value of this series converges, and that means it converges absolutely. It has absolute convergence. You don't even have to check the alternating. You don't have to use the alternating series test. In other words, so that's the if you get absolute convergence, then you're good to go. You're done. So we'll do it with this one as well. So let's see. We're looking at this series now. We haven't really spent a lot of time figuring out if one of these series converges or not, but we do have tests, and this is, well, we can compare this to a P series because n factorial is going to get huge really, 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 really quickly. So this is most definitely less than this. I'm not going to use 1 over n because 1 over n converges. I'm sorry, diverges, and that won't tell me anything if it's greater than this. But I know for a fact 1 over n squared is a convergent P series, and that's definitely a greater value than 1 over n factorial. So since this converges, so does this by the direct comparison test. Thus, the absolute value of this series converges, and thus, this alternating series converges conditionally. So I hope you followed that. So we'll do the same thing with this one. The absolute value of this one is 1 over m plus 4. I'm going to immediately compare that with a limit comparison test to 1 over n. And we know by the limit comparison test that this means that this series will diverge. Now, that's the absolute value of the series diverges. I'm not sure about this alternating series. I have to use an alternating series test now to see if the alternating series converges. So I go back to this alternating series test where the limit must be 0, which it is, and the n plus first term must be less than the nth term, which it is. So true, true. That means this alternating series converges. But since the absolute value diverges, we're going to have to say this converges conditionally. So again, that just really means, if you think about it, it's kind of dumb, but this series converges only under the condition that it's alternating. If it wasn't alternating, then it wouldn't have converged. Number 10, same question. The absolute value of this, this is an easy one. I can see right now. This series diverges from the nth term test because the nth term is 1 over 3. So let's say nth term divergence. Done. Number 11. So we have the absolute value here is e to the negative n to the 5th. Wow. Well, that's going to be 1 over e to the positive n to the 5th. So it's a really strange looking series. However, it's really pretty simple because this number down here is pretty big. Much bigger than if it were, say, n squared. So that's an easy inequality. 1 over n squared converges, so that means this converges. So this has absolute convergence. Number, whoa, where's number 12? I don't know where number 12 is. Did I lose it? Well, number 12, you're going to have to fend for yourself there. Actually, I'm going to do the next question will be on the next video because I see a very different question coming up. So stay tuned.